A ball is thrown in the air from the top of a building. Its height in meters above the ground as a function of time in seconds is given by h of t equals negative 4.9 t squared plus 21t plus 11. How long does it take to reach maximum height? Round to the nearest hundredth of a second. Alright, so let's take a moment to sketch something. You wouldn't believe how much easier word problems get when you draw a sketch of things. And this is a fairly realistic experience that one could have in life, standing at the top of a building and throwing a ball. And even if you've never done that before, it's something that you could at least picture in your mind's eye. So here we have a building, and from the top of the building we have a ball that's going to be thrown. So the ball's path, as it's thrown, is going to increase for a little while, but because of the effect of gravity, it'll eventually reach a maximum, and then it'll start turning downward and drop down to the ground. What is very interesting is that because we have a effect due to gravity, the path of the ball will be a parabola. And we know the path of the ball already. That's given by our function h of t. So this maps out this parabola right here. So the question is looking for this maximum height. And if you'll notice, it's at the vertex of this parabola. So the maximum height is at the vertex. So the question is really asking, what is the vertex of this parabola? And we found multiple different ways of determining a vertex of a parabola. One way is to use completing the square process, but I generally only pick that if the coefficients are easy to work with. If they're not easy to work with, it's probably easier to use the vertex formula. So the vertex of a parabola is negative b over 2a, comma, f of negative b over 2a. So the x-coordinate of this vertex is going to be at negative 21 over 2 times negative 4.9. Now, this is not necessarily going to end up being integer values as our answers, so let's go ahead and let the calculator help us out. So negative 21 divided by, I'll put in parentheses, 2 times negative 4.9. So 2.14. It was to the nearest hundredth of a second. So 2.14. That's going to be the length of time, because this axis going this way, this is time changing. So I could probably say that this is, actually I should, because it's h of t. So obviously I should call this t. All right, so t equals 2.14 seconds. So that's how long it takes to reach the maximum height. If we wanted to know what the actual maximum height was, then we could take this value and plug it into our function. But the question here is only asking for how long it will take before that happens. So there we have